Okay, I think I'm in the middle. Yes. Okay. So I think maybe near the front. Yeah. Yeah, I put some in. I thank Joel for his years of suffering. You're ready. We'll... We're ready to go ahead. Good afternoon, all. Welcome to Dnsop. So, a good after lunch thing. We'll slide a bunch of stuff through when everybody's asleep. I'm Tim, and this is Suzanne. Sorry, I'm working off a cold. Do we have anybody who can Jabberscribe? Did Dan sign up? Dan, thank you. Dan York, Jabberscribe. And we need a second minute taker. We need someone to sort of help with the minutes. Anybody? We can use the Etherpad. Everything's already preloaded in the Etherpad. Please step up. I'm going to... Okay. Now I'll be cranky, but okay. So we'll figure something out. Please note the note well. Most of you have been here before, so you've seen this. Please just, if you haven't, just please note it. And please fill the blue sheets in. It's how we tell the secretariat we need a big room with lots of microphones. So, and this seems to be a kind of a big flat room, which is sort of strange. Our agenda, we've got some updates on some old stuff, some current stuff, and some new working group business, as the flow never seems to stop. So we'll get into the document updates. Since our last meeting, we have a new AD, yay. But we want to thank Joel for his years of suffering, and we want Warren as our new AD to come up and say a few words.
Wow, I'm still too short.
Yeah.
So hi everyone, I'm the new Joel. Yep, but better looking, of course. So that wasn't a joke. So I have a whole bunch of drafts already in Dnsop, and I've discussed this with the chairs. And so the way we're going to deal with that is the chairs are just going to treat me, as any other participant, and they say that they're perfectly fine to, treat me like any other participant and tell me when I'm being stupid. Yeah, I know.
Yeah.
And when these go through IETF last call, they will just have a different responsible AD, like Benoit or Terry or somebody to actually shepherd them through the process. And I mean, this is a fairly well-known and understood system. And yeah, hopefully this all goes well. As I say, I'm new to this, so if I do anything stupid as an AD, the chairs are free to bang me upside the head with a cue stick. Yep. And now I'll put this back to normal person height.
Yeah, I feel confident we can manage Warren very well. So, but thanks again to Joel. We put a lot of work through him in the last couple of years, so he suffered it, magnanimously. So,
thank you, Joel. Who appears to want to say a few words? Yeah, so we've been on a bit of a productivity streak for the last 3 years, which I think is mostly in the hands of the chairs, not myself, but I think that is something we should congratulate ourselves for generally, because we've brought work here, we have achieved consensus on it, and we've advanced it, and we seem to be on the verge of doing that for some rather important documents for one of our milestones. So I think that's something that we should be proud of.
Yeah, true. I think the group should be very proud of that, actually. So,
Thanks.
so since our last meeting, speaking of which, roadblock avoidance is now RFC 8027. Resolver priming hit 10 years and now is RFC 8010. So thank you, Paul, for dragging the previous authors along with that. And the maintain DS is now RFC 8078. So, you know, we've kept up our our streak of trying to produce 3 documents per meeting, which is a pretty strong clip. So, you know, I know it's been a lot. So another stuff that's kind of in our queue, the NSEC aggressive use is in IETF less call. I believe I actually saw an email saying that it may have finished today. And then the key tag draft, which is in the RC editor queue. So those things will probably be coming out fairly soon as well. Also, the refuse any draft, which has been, we went through last call, it had some updates. The authors got lost, they came back, and we're in working group last call again, and it should end Tuesday night, so tomorrow night. So if there's any comments or questions, please hit the list with them, but it looks like we're in good shape and we're ready to sort of move that one forward. So thanks to the authors on that. And on the IP6 draft, we found an additional author to help Lee, because Lee's out trolling the IPv4 people. And I think we've got some working group concerns that I think they're being addressed, and we'll probably take it back to working group last call once those things get sort of sorted out. Also, we've got one document currently candidate for adoption. It's the RFC 5011 security considerations, and that ends Wednesday night, I believe that is as well. So, or Tuesday and Wednesday morning. If there are concerns, and I believe most of the things have been addressed that have come up on the list have been addressed, and I've chatted with the authors about that, and they seem fairly good about that. So that one looks like it's going to be adopted here as well. The alt-TLG draft, this is sort of the update from the interim. The working group last call started, but it kind of got a little bit lost in all the mailing list activity, but it's going to get extended till after the end of 98. So, and then also on the special use TLD problem statement, the authors have addressed all the outstanding issues. The interim meeting sort of discussed the changes. It seemed good. And we believe there's consensus to move this forward as an informational, informative RFC. So that's kind of, you know, that's the next step for that. So, which is good. That's been a painful process, but thank you. Yes. There was no response issue. I believe that's ready for working group last call. There's one current outstanding comment section from Petter that I want to go through with the authors on, but I think we're getting ready to move that one forward. And I was going to say the session signaling draft is ready for working group last call, and Stuart has 60 seconds to say something about that.
The authors just had a little meeting about that before this. We think it's pretty much ready. There's a couple of little wording changes we're going to update. We're going to add a statement that name compression is not allowed because it doesn't say that. We had feedback on the list, which you may have seen, saying that if the 4 traditional sections are not empty, that should be an error. It currently says silently ignored, but it seems like a good suggestion to make that an error. So if I don't hear any objection, we will make those changes. We'll give it one more read over for readability, and our plan is to submit an update 2 weeks from today that should be ready for last call.
Cool. Thank you, Stuart. And then, of course, the big fun one, the RPZ draft. Its idea was to be informational only, initially capturing existing current behavior. If everybody wants to sort of fix it, they could do it in the sort of the biz draft. And of course, that was not new territory for us. There was some, you know, very, very interesting sort of, you know, mailing list conversations on this. We do run into a process problem. we can't have a working group document that doesn't allow derivative work, which currently it does. It has that disclaimer in there. And so we're working with the authors and the ADs on how to proceed with this. The authors are they're positive about actually removing that and moving it forward. They just, it's just a conversation that has to get done. So, and I think I feel positive, but I'm kind of an optimist and kind of bullheaded that we can make that work with the group. So I may be wrong on that. So yeah, we've done lots of comments, and we thank you all for all the comments and all, especially and all the feedback and all the documents, because I do think what has come out of a lot of those have been much better documents that have gone through the ISG. Some of them have gone through so smoothly that I've been a little surprised, but I think a lot of that is from all the reading and review that we get from the group. So we can't thank you enough, but it just never seems to stop. Of course, you notice that. So, ooh, that went bad. What are we working on? We've got a list of the documents in SVN, but Paul, and thank you for Paul, our secretary, for sort of keeping that up to date and keeping us on task, making sure we're not forgetting all this stuff, because there are so many moving parts going on that it is easy to sort of forget some of the things happening. So the agenda sort of changed a little bit. Where Paul's going to do a little update on the terminology BIS, but in a minute. And then Sharon is going to present remotely about NSEC 5, and due to a time constraint, we're trying to put her in next, and then we'll sort of jump back to the other stuff. Capture format, these are sort of things we're working on. 2 discussions about algorithm updates, a little bit back and forth on those. And then there's a bunch of stuff in here. These are sort of new things that people are interested in. As I said, sort of possible candidates for adoption, some feedback. There's some interesting stuff on the list. May not get to all of them. Of course, we're very optimistic about how much time we have. So I think if we actually had a 4-hour session, we could probably fill the whole thing. So, so that's that. So Paul, you want to do terminology?
Sorry, quick agenda bash. I thought I was on the agenda, but I see I'm not.
Oh, you're on the agenda actually.
Okay, well, I wasn't on the slide.
Okay, because you're on the other agenda. Yeah, sorry. I know you're on the agenda, so sorry about that, Ray.
So, hi, terminology BIS. This, often people say, oh, look what we've changed and stuff like that. That's not what this is about. We want to hear some feedback. Wait, I don't want it to go that fast.
It started jumping on its own.
Okay, thank you.
Okay. There we go.
Next, yes. Okay, so the big thing here that what we're trying to get today in the room to get people up to the mic line is the fact that we added some new stuff in section 2 since the last meeting. We've talked about it on the list a little bit, but we've gotten surprisingly little feedback. And when I say we, I mean Andrew Sullivan and Kazunori and I. We added 3 important things. We described a naming system. So we invented this term out of whole cloth, which is what we're generally not trying to do, but we don't think we clashed with anything on this. Andrew, are you glaring at me or looking at me? I just, us to define locally served DNS zone because that was already in another RFC. We did that. There was the question of QName that I guess it came up either here or in another working group, that there were two definitions of QName, the one that everyone sort of understood, and then the one that was in 2308, which was really specific to 2308. So we actually did those, and then we added recursive resolver just because that's something a lot of people have been asking for. And it was so we will have another draft hopefully within about the next month. We have a GitHub repo where we're keeping issue tracking, and please follow that if you can, but we're happy to take things on the list. We will keep the two things in coordination. But now we're thinking maybe we should be done with this one maybe in the summer. So please start paying more attention. Don't wait just for working group last call. Because again, the outside world is starting to look at this, which is sort of cool. Thanks.
Sort of cool, but does sort of put you on the hook. If we can get remote.
If we can get Sharon to show up remotely, that may be broken. Yeah, we wanted to jump to Sharon because of her time constraints, but now we seem like Meet Echo. Okay, okay, great. So there we are, Sharon. Talk to us, Sharon. No.
Okay, hi, can you hear me now? Can I start? Okay, sorry about that. First of all, I deeply
Yes.
apologize for not being there in person. I had every
Yes.
intention, and then this family emergency happened, so I'm sorry to be remote. Okay, so I wanted to give you an update on the NSEC 5 draft that we've worked on quite a lot in the last couple of years in response to feedback from this community. So I have a lot of new things to report. So let's just get started with the next slide. Next slide. Oh, okay. All right. So there's a delay. Okay. So NSEC 5 is meant to be an alternative authenticated denial of existence mechanism for DNSSEC. So what I'm showing on this slide is the different approaches that you can do to answer queries for names that do not exist in a zone in DNSSEC. So the first thing you can do is you can just use DNS in the first row. In that case, you're not vulnerable to the zone enumeration problem, but you have integrity. You do have a problem with integrity. Then there's the sort of traditional DNSSEC way of dealing with answering queries for names that are not in the zone, which is NSEC and NSEC 3. This is an offline signing solution that does not require zone signing keys to live on the name servers. But these are vulnerable to zone enumeration. So NSEC is vulnerable just to very simple zone walking, and NSEC 3 is vulnerable to zone walking through dictionary attacks. So because of short time, I'm not going to get into any of these details right now. But I just want to point out that there's a trade-off between this very, very nice integrity guarantees where no crypto keys have to go on servers versus the zone enumeration problem with NSEC and NSEC 3. Now, the opposite sort of solution is to use an online signing approach like NSEC 3 white lies. In this approach, what you're doing is you're putting the zone signing key on the name server and you are responding to queries for names that don't exist by signing responses on the fly. Because the zone signing key is on the name server, you have a problem if the name server gets compromised. So that's why I'm showing in the third column integrity versus compromised name server does not hold for online signing. But of course, it does prevent zone enumeration. So what NSEC 5 is intended to do is it's intended to both prevent zone enumeration, and it's also a solution that's very similar to offline signing in the sense that we don't have to give the zone signing keys to the name servers, and if the name server is compromised, we don't lose integrity. Okay, so how do we actually do this? The way we do this is it's very, very similar to NSEC 3. So if you're familiar with NSEC 3, all you have to do is take away the SHA-1 hash and replace it with a verifiable random function. Okay, so a verifiable random function, we're actually going to present this at SAG on Thursday. We have a separate draft that we've pulled out of the NSEC 5 draft for this crypto primitive. What it is the public key version of a cryptographic hash function. So in a normal hash function, anyone can compute the hash, and anyone can compute the hash. In a verifiable random function, you need to have a secret key to compute the hash, and then you can verify that the hash is correct using a public key. So it's a public key crypto version of hashing. Okay, next slide. So NSEC5 is an offline signing solution in the sense that the holder of the zone signing key is going to prepare the NSEC5 records in advance. So here's what it's going to do. It's going to take the names in the zone. It's then going to hash them using the verifiable random function. So the verifiable random function has its own cryptographic secret key. This is separate for the zones from the zone signing key. We call it the NSEC5 key. And basically, you're using this VRF to compute hash values just as you would with NSEC3. Next slide. Then what you do is basically for every name, you hash that name using the VRF. Next slide. And then what you do is you get a bunch of hash values. Now, this is exactly what we would do in NSEC3. We take the hash values for the names in the zone. We sort them in alphabetical order. And then we take every pair and sign that pair. And that pair is an NSEC record. So in NSEC3, it's an NSEC3 record. Here you see the NSEC5 record, where we have the first two hash values in the zone signed together with the zone signing key. That's the first NSEC5 record. And you can see there the full NSEC5 chain. Okay, so basically we've replaced SHA-1 hashing with the VRF. Next slide. So you may be wondering what this VRF looks like, what it actually is. Here's a really simple way to think about it. You can think about that function pi there that uses the secret key. You can think of that as a deterministic public key crypto signature. And then this H that you see outside basically takes a hash of this deterministic signature. Okay. So in this version of the draft, which has changed a lot since the last version you may have seen, this set draft uses exclusively elliptic curves. So the verifiable random function that we are using is based completely on elliptic curves. We used to have it based on RSA, but that's been removed. And what's going to be important for us is the length of the output of this pi function, which you can see there with the key. And that output is 641 bits, which is a lot shorter than what it was with RSA, which is why we're going to see a lot of performance improvements, as I'm going to show you as we go on. Okay, next slide. Next slide. So next slide. Slide 8, please. Okay, so great. So how do we actually use NSEC5? What happens is we now have two public keys. We have the zone signing key, the regular DNSSEC key, and then we have this key to the verifiable random function, the VRF key that you see in yellow. And now when a query comes in, you see q.com coming in from the resolver and going to the name server. This name server has the secret VRF key, which you can see under the server. And in order to actually compute the hash of q.com, it needs to use the VRF. So if you remember how NSEC3 works, this would just be a normal SHA-1 hash. What we're doing here is a VRF hash. So first we compute the 5 function, then we take h of that output, and then we send it back. Then we have that value that starts with 7. Next slide. So what happens next is that the server will respond with an NSEC5 record, and the record that is used is just the one that covers the hash value. So you can see that 7 falls between 3 and 8, and that's why that NSEC5 record is the one that's being returned. Okay, so now you might be wondering how the resolver is actually going to verify this NSEC5 record. So the way this works is we use a special aspect of the VRF, which is called the VRF proof. So you can see in the top corner of the slide, I have the value proof AA8678. What happens is that the name server is going to send that proof as well. So next slide. And so what the resolver is going to receive is 2 records. It's going to receive the NSEC5 record, and it's going to receive what we call an NSEC5 proof record, which contains the proof value. Okay. Now, the combination of these 2 records are going to allow the resolver to verify. Let's see how. Next slide. So what's going to happen is the resolver is going to do 2 checks. First thing he's going to do is check that the NSEC5 record is covering the query. So the way he does that is he takes the proof, he hashes it, and that gives him the NSEC5 hash value of the queried name of q.com. Then he just checks that the NSEC5 record is properly being covered. So you can see that that the hash value falls between the 2 numbers in the NSEC5 record, so that's good. And then the second thing that he needs to do is verify that the proof is correct. And so the way he does that is he takes the public VRF key, and he verifies the proof against the query. And again, as I told you, you can think of this output of the pi function as a deterministic public key crypto signature. So this verification is just like a crypto signature verification. Okay, so that's how NSEC 5 works in a few seconds. Next slide. Next slide. Okay, great. So just to summarize what's going on with this proposal, okay, so NSEC 5 prevents zone enumeration. Why is that the case? Because we're doing hashing with a verifiable random function, no one can compute hashes on their own. They need to actually go to the name server. So that means you can't start querying the zone, collecting a whole bunch of hashes, and then using them for offline dictionary attacks the way you would have with NSEC 3. Okay, so that's coming from replacing the SHA-1 hash with the VRF hash. Okay. The next thing is we have integrity versus a compromised name server. Very simply put, the reason that this is the case is because the zone signing key is not given to the name server. And it turns out that even though the name server does have a secret key, which is the secret NSEC 5 key, it's different from the zone signing key. Even with the knowledge of that key, he cannot cheat and sign bogus responses for names that are not in the zone. So that key does not allow him to send incorrect information. Okay, so that's the second aspect. And then the third thing is you've probably noticed that the name server needs to do an online crypto operation every time he gets a query. So why is this happening? Because the verifiable random function, that pi function, is like a crypto signature. That is a crypto computation that's very similar to what you would have had to do in the online signing approach. Okay, so in terms of performance, we're looking at comparisons against online signing. So just to summarize why I'm showing this slide is because NSEC 5 provides an alternative to online signing for DNSSEC in that it doesn't require giving away the zone signing key to the name server, which could then get compromised. Okay, so that's the main advantage. And now I want to show you some performance numbers very quickly. Next slide. So we've done an implementation of this. And you can see some of the details there. We've done a lot of work optimizing at the DNS level. Next slide, please. We've done a lot of work optimizing at the DNS level, so we've used really good ideas from the Gibbings and Meckings draft on NSEC 4. And so because of all these optimizations, we can actually show performance that kind of similar to NSEC 3 white lies. Online signing solution. So here's an empirical measurement we did. This is coming out of our implementation of NSEC 5 of the different response lengths in DNSSEC. So the first column you see is NSEC 3 with RSA 2048. The reason I'm showing you this is because the security level of RSA 2048 is roughly the same. In fact, it's less than the security level of the elliptic curves that we are considering for use with NSEC 5, which is the P256 NIST curve and the ED25519 curve. Okay, so this is a lower security level. You can see the responses are a lot longer. If you compare, again, NSEC 5 and NSEC 3, the two middle bars, both of these are using the NIST P256 curves. You can see that NSEC 5 response lengths are only slightly longer. And I just want to point out that NSEC 5 response lengths with the curves that we're using are actually shorter than what's currently being used in most places in the field, which is NSEC 3 with 1024 RSA. Okay, next slide. So the really big question here is what does performance look like at the name server? Because the name server for every query has to compute the VRF hash, which is like computing a signature. Okay, so what does the performance look like? So this is performance. You can see we'd have 24 threads on 40 virtual CPUs. On the x-axis, you can see the query rate. We have a steady query rate of negative responses. So these are all eliciting NX domains. You can see that and this is a logarithmic scale. You can see throughput on the y-axis. You can see first thing that when you use NSEC 3, performance is much higher. The reason for this is because there is no online public key crypto computations being performed at the name server. So the real comparison to do is to compare NSEC 5 elliptic curves with NSEC 3 online signing elliptic curves. And that's what you see, the green line versus the purple line. You can see that NSEC 5, with the setup that we have here, will take 64,000 queries per second before it starts to max out. Okay, so that's the performance I wanted to show you. And I'm going to stop here and show the last slide. So those are all the resources we have for this project. Because I'm unfortunately not physically there, I'm going to refer all the questions to my co-authors, Dave and Shuman. Thanks.
Thanks, Sharon. And we have Dave Lawrence and Shuman to sort of moderate conversation here. We have a few minutes. Comments, questions? Thank you so much, Sharon, for making the effort to talk to us.
Do you have anything you want to say first?
I don't.
So fire away.
Hi, this is Andre. I like what you did with the NSEC 5 draft. It's much simpler than it was before, and I think it might clear some Andrew's concerns about this being too complicated, because I think this is not complicated at all, and it would be quite easy to implement this as compared to existing crypto. So I would really like to get this adopted and implemented and standardized as IETF draft.
Yeah, I think I agree. If you understand NSEC 3, this is not a radical change from here, from how NSEC 3 works. And it also comprehensively solves the zone enumeration problem.
Hi, Medica Kao. I did see the presentation at the NDSS conference as well, and it was excellent. I have a minor nit. Security is fairly, and crypto specifically, is fairly difficult. I looked in the draft real quick. It does say private key. So when you say secret key, that means symmetric encryption. So as we're speaking of it, please make that distinction to use private key, because that means asymmetric encryption.
Oh, definitely, 100% agreed. If there are indications of that in the draft that you've seen?
No, it was just in
okay.
the communication.
Oh,
Yeah,
okay.
but thank you.
Hi, Evan Hunt, ISC. This is very clever work. I've been following it since it was first announced, and I think it's a really elegant solution to a problem that I'm not convinced we have. The rationalization for NSEC 3 back in the day was that there were large operators of very significant zones who, due to legal or contractual requirements, could not deploy DNSSEC unless we addressed the zone walking problem in some fashion. And we have addressed the zone walking problem in some fashion well enough that all of those operators that I'm aware of have been able to deploy DNSSEC now. I haven't heard anybody say they can't do DNSSEC until there's something like NSEC 5. And without that, I'm not sure why it's necessary for Dnsop to adopt the work. But I do think it's a good solution. I just need to be assured that there's a problem.
Can I speak to that?
Yeah.
This is Daniel Kahn-Gilmore from the ACLU. I'm in touch with several groups that don't want to deploy DNSSEC because they don't want the zone enumeration problem, and they're not convinced that NSEC 3 solves it for them. NSEC 5 would solve it for them. There is a demand for it.
Yeah. The other comment I would make, Evan, is maybe the TLD operators who have deployed NSEC 3 are not aware of the fact that there are a bunch of researchers at many conferences recently that have used offline dictionary attacks with NSEC 3 to comprehensively enumerate zones to do things like, statistics on those things, right? So there is a problem that NSEC 3 is vulnerable to in the field that NSEC 5 can address. So I think part of that is some education needs to happen with the people who have deployed NSEC 3 who may not be aware how relatively easy it is to enumerate those zones.
And I'll just add that the zone enumeration problem is just one of the aspects that it's addressing. One of the other things for my own interest in it is the dynamic signing speed and what that does as far as resiliency of the authoritative servers to attacks. Now, Paul Hoffman did raise an interesting objection on the list that he wasn't entirely clear whether the 2x performance gains were over a similarly optimized NSEC 3 white lies implementation, which is something that should be clarified in the drafts. But overall, needing fewer signatures to establish verifiable proofs against wildcard expansion as well makes this still a very attractive proposal for increasing the performance of denials.
Dan,
Guys, hold on a second. We'll be closing the mic. Closing the mic,
So,
please.
Dan, you were jumping in for Jabberscribe for Sam Weiler. He asked a question for DKG. Can you get them to explain the requirements to us? They don't want they don't want zone enumeration, Sam, is what they're hearing. There are a number of people on here. Suzanne, I have several questions. What do you want me to do?
Go ahead with another one, and then we'll go on.
Okay, so one from Victor Duchovny was to you guys, are you planning support for X25519? Should P256 even be used, given that this is new?
Right. So I can quickly answer that. So if you look at the current version, so the implementation work that Sharon described in our talk is based on NIST ECDSA P256. However, the draft that we recently revised does include a VRF construction for 255, curve 255.19. So we plan to support that.
Okay, then another one was, again, was as to TLD enumeration, most TLD zone data is available for download via CZDS or something similar. Again, from Victor.
Yeah, so this is, that is not uniformly true. That is the case for a large swath of the new GTLDs, I think all of the new GTLDs, but there are many TLDs that are exempt from that requirement. Which is,
Okay, my last question then for Relay was from Peter Koch. How would, well, actually first, I will just go, Sam Weiler did come back to DKG saying that doesn't explain how NSEC 3 doesn't work. More details or it didn't happen. So going back to Mr. Koch, how would NSEC 5 interact with aggressive negative caching?
Yeah, so that's a good question. I think the way NSEC 5 works, it would not work.
Can I add to that?
Negative caching. Is that right?
Yeah, so aggressive negative caching, there are two ways that it works as I understand it. One way that it works is that you can basically, instead of answering, so if you have an NSEC 5 record that has 2 hash values, in NSEC 3 you could compute your own SHA-1 hash and see if the query you're getting falls between the NSEC 3 record that you already have in your cache, right? With NSEC 5 you could not do that. Okay. What you could do with NSEC 5 is you could do the other part of aggressive negative cache, is that you could look at the type bitmaps and use that. So if you queried the same name with a different type, you could use your cached information. Okay. So the aggressive negative caching is basically using enumeration. And we're trying to stop that. That's why it doesn't work right out of the box like that.
Other microphone, please.
This is Andre. I also want to add to what DKG said. I also have anecdotal evidence that there are people that have this problem. So I would be very careful about saying we don't have a problem. I think we can say that there is a problem, and there are some people who have concerns about zone enumerations using NSEC 3. So, and if there is a problem, I think that we should have a solution for that problem. So just be careful with using we, because that's very vague who we are.
Right, yeah, so I agree. And then speaking of communities that may have problems with this, one other community that I think we need to pay more attention to is security in the cryptographer community. To them, every time you talk to them, the fact that this protocol is almost trivially vulnerable to offline dictionary attack is an obvious defect that should be fixed, and it is technically capable of being fixed. So, you know, I mean, often the crypto community comes up with requirements that are not practical, but I think in this case we're showing there is a practical and performance solution that exists.
My name is Andrew Sullivan. I want to ask maybe a little bit, just to follow up on that, about what we mean by practical. Because there are, you know, sort of 3 dimensions to this, right? One of them is whether you can implement this. A second one is what the cost to deployment might be if we go ahead and do this, and the cost to existing deployments as well. And then finally, what's the cost to the standards process and the code that's already in the field that needs to be maintained and so on. And I think there is strong evidence here, actually, that the first case is trivially addressed by this. But we've got also, you know, sort of a resource problem, both in the maintenance of existing code bases and also the effects it might have on you know, this working group and whether it can pay attention to other things that are maybe, you know, pressing as compared to this. Like there's just you know, your limited resources. What are you going to do with them? And similarly, you know, what does this do for the deployment of existing things out there in the world? Because, you know, literally, we've now had more than 10 years of attempting to get people to deploy DNSSEC, and we've got like this much deployment, right? And what we're about to tell people is, and by the way you've already done this, you need to upgrade everything again in order to get this thing to work. And I'm very, very nervous about that piece of this. So I don't object to this work going ahead. I think it's good work. Like, I think there's really interesting stuff there. But when you're talking about deploying things at internet scale, there are in fact deployability considerations that really need to be taken into consideration. And I think part of the question that we really ought to ask ourselves is whether the cost here, or whether the benefit rather is worth the cost potentially to deployment. And that's part of the question that I guess I would ask the working group in evaluating whether we should adopt this or just say, yeah, sure, you can talk about it here and go ahead and build, ship this as experimental or something like that. See whether it gets picked up. That would be a way forward that might not present those kinds of problems. I don't know, but I am very, very worried about the potential for deployment effects here.
So I do agree with you that we need a more complete story around the deployment issues, and not only deployment of zones that are being signed initially, but also for ones that want to transition. But as you say, I think it's good work that should go forward while we work spend a little bit more time coming up with the deployment stories.
Yeah, and I'll quickly add that I certainly agree, Andrew, that there is a significant deployment cost here, and that's a conversation we need to have with the working group. But I would point, as I pointed out on the mailing list, on the horizon, we have several other potential algorithm transitions that will impose a similar huge cost. So I think part of our task is to figure out which of those are useful to the DNSSEC protocol going forward. And it might be helpful to see which one of those we can lump together to minimize how many times we have to go through this algorithm rollover cost.
Paul Vixie, Farsight Security. I have a public service message for the ACLU, or indeed anyone who thinks that zone enumeration through DNSSEC is a problem that must be solved. I would like to give you a free demonstration of passive DNS. If you can't find me, our CTO, Medika Keo, is also here this week. Thank you.
Last, Mike? You're welcome, by the way.
Thank you. Roy Adams, ICANN. I sympathize with you. I was in the same position when trying to deploy NSEC 3 with opt-out. I still bear the scars. So I won't say anything about the need for this, because I've used the same arguments that you will use in order to get this progressed. I have a question, a very simple question, and I think it goes down to the fundamental issue of having keys online. You generate an NSEC 5 record on the fly. For that you use a online key that you can't use for anything else. Oh, sorry, I see Sharon shaking her head. Maybe not on the fly, but you need to generate the RRSIG records over that, which basically needs yet another vanilla DNS key. Is that not correct?
This is actually not that easy to
And if you
understand,
have
and I
another
didn't have
vanilla
time to explain it properly, so I apologize. Let me try to do it quickly, okay? I don't have the slide for this. NSEC 5 RRs are pre-signed. They're generated offline. The RR6 for those records are generated offline using the zone signing key. Okay, what's generated online is the NSEC 5 proof record. That does not have an RR-SIG. It's just an NSEC 5 proof record. The work to generate that record is like doing a signature, but the key that you're using to do that to generate the proof record, which is synthesized on the fly, is like doing a crypto signature, and it's done with the NSEC 5 key. Okay, now if this NSEC 5 key is leaked to the public, let's say I just publish it on the internet, okay, what will happen to your zone is that it will be easy to enumerate because you can compute hashes, but you will not be able to attack integrity and return bogus responses. That's the big difference between this and white lies. And why this actually works is not totally clear, and I don't have the time to explain it properly. If you want to look at the talk I gave at Real World Crypto, I explain it there. But if you leak the zone signing, the NSEC 5 key, if you leak the NSEC 5 key because your server is compromised, what will happen is NSEC 5 security looks just like NSEC 3. So you can do dictionary attacks using that key, but that's all you can do with it. You can't forge anything. You can't give wrong responses.
Okay. Thank you. I will.
Yeah, we're
Thank
over
you,
time,
Sharon,
and
for
we
your
need to go back to the
explanation.
mailing list.
Sorry, may I?
We're over time, and we need to go back to the mailing list from here on, but please finish your comment.
Okay. Sharon, thank you for that explanation. It's clear to me now. Cheers.
Okay, and thanks, Sharon.
Thank you, Sharon.
Thanks, David and Shimon. And next we have CDNS. Sarah?
Okay, my name's Sarah Dickinson. I'm going to give a quick update on the status of the draft on the CDNS format. This is a DNS packet capture format. To briefly go over what this format is trying to achieve, the goals were to produce a very efficient format for storing large packet captures of DNS data. We targeted collecting packet captures in restricted environments, so we want to make this efficient to produce and also as efficient to store as possible. So the smallest file size was one of the primary goals of this format. We also would like it to be reversible, and it kind of almost is. So you can go back to PCAPs from this in a lossy fashion. So the basic principles of the design are we pair up queries and responses. We group those query response items into blocks of, we found a few thousand items is about optimal. We then abstract the common data from among those queries into separate tables that are indexed from the individual query response items. And this, we have a core set of data which is collected, but you can optionally also collect everything that actually is in the DNS payload, so all the sections and all the RRs. That's what the format looks like. So there's lots of arrows all over the place. You'll see on the left-hand side there is the base query response record. So every query response pair has one of those, and from that item you index into all the other tables which hold all the common data. So where are we with the draft? The draft was adopted by the working group last November. We've done one revision since then. It was fairly comprehensive in terms of it being an editorial update, so there were no major changes to the structure of the format, but we hope it is now much more readable and much more consistent, because there were some issues with that. In response to requests on the mailing list, we've added an option that within the same file, you can store in a table the wire format of malformed packets. So these are packets that are so malformed that you can't parse them well enough to be able to store the data in the structured CDNS format. So this is a simplistic option. It's just if I can't parse it, I store the whole message. But this seemed a reasonable starting point for that handling. There were some very minor tweaks to the details. We've increased the timestamp resolution to picoseconds. We added a handful of fields, we reordered some, but nothing major. Comments on that version of the draft that we've had are, again, some housekeeping issues to do with how configuration options work and terminology. So we still have not had any comments that we have got, that people think we've got something fundamentally wrong in the way we are structuring the format. So that's really good. We're really happy to hear that. But what we would like is if people can review it, and if they do think there's something wrong with the format, the earlier we identify those issues, the better, particularly in terms of ease of backwards compatibility for early implementations. So the one remaining question we really do have in the draft is whether or not we should attempt to do something more sophisticated in terms of our handling of the malformed packets. So it would be great to get some feedback on that. And I will just finally note that as I was reading the draft preparing for this talk, I realized that the images of the structure that are in the draft are the ones that were in the OO format, OO version, and are incorrect. They don't align with the CDNS format that's there. Apologies, and we'll put an update out very soon to fix that. So that's everything I had to say. So I'm happy to take any questions.
So I think the immediate question in front of the group is there major suggestions for additional work to do, or are we ready for working group last call? Center microphone, please.
Hi, Roy Adams, ICANN. I love this stuff, but then again, my colleagues are co-authors on the draft, so that shouldn't say much. On the open question of partially malformed packet handling, maybe an idea is to, if you can't parse it, preserve it and dump it in some bucket somewhere.
Mm-hmm.
Thank you.
Brian Dixon, now at eBay. One question, I apologize for not having fully read the draft, is a question about compression pointers and validation of those, or whether there's any semantic validation of compression pointers.
So what we do when we actually write the data into the CDNS is we fully expand all the names. So we store them expanded so that you can, when you go back to PCAP, you can regenerate that using any compression algorithm you choose. If that answers your question.
Possibly, I'll have to look at it, but there are places in, or methods that could be used for generating incorrect but syntactically valid packets where compression pointers might point to something that's not really something real. And I'm not sure if that'll break things.
So if in terms of parsing, the original parsing to query or the storage?
Both, I think.
So if we cannot pass the query, oh, sorry, if we can't pass the message to a sufficient level to decompress all the names, then we don't consider it well formed and we don't attempt to store it in this format.
Maybe I'll follow up offline.
Yeah, okay.
Hi, Mike Ackerman, interesting work. Do you have any field results that show how much you save percentage-wise over raw PCAP, or what factors might cause that to vary?
So it obviously it varies with the data. The data sets that we've been working with are from one of the root servers. And on that data set, if you're using aggressive compression, so we will create a CDNS file, and then we will use a general purpose compression tool to compress it further. And if we use aggressive compression, then the files are 30% the size of the PCAPs.
30, and that's pretty consistent?
Yeah.
Okay. Thank you.
Dan York, just jumping in as Jabber Scribe to just say, we do have a significant number of remote attendees. So if people can clearly say their name when they come to the mic, that would be hugely helpful. Thank you.
Process interrupt is always in order. Thanks. Far right hand mic, please.
Thank you, Jim Reed, RTFM Limited. Sarah, this is great work. I think the draft's coming along quite nicely. But I seem to remember when this was presented and sold, there was some discussion about some IPR issues around this stuff. Could you clarify where we stand with that, or is that perhaps out of scope at the moment?
We are in the same position we were then. There was an IPR disclosure against the draft. To my knowledge, nothing has happened relating to the applicants of the patent. They haven't made any statements with regard to this work, to my knowledge.
Do you have any view for when we might be able to get some kind of resolution on that?
I'm afraid I don't know.
Okay, thanks.
Lars Liman from NetNode. Regarding malformed packets, I see two uses of this type of storage. One is when you want to do statistics. I see two types of uses for this. One is when you want to do statistics. The other one is when you want to investigate an ongoing attack. And they are quite often by malformed packets of various kinds down to totally unreadable. So that may be the thing that you want to get back through a rather congested wire or thin wire from a remote location. So I would strongly suggest, or I would like to show my interest for having malformed packets be handled by this in some way. And it doesn't have to be now, but if you decide for not now, then please try to make it so that you in the future can add that as a feature in version 2 or whatever.
So, sorry, I perhaps wasn't clear. In the 01 version, we've added into the format an additional table that goes in the same file that holds the wire format of any malformed packet. So it's a very, you just dump the wire format in there, but at least then they're all transported in the same file.
Yeah, but the problem is that then you don't have any size gain. There's no compression, so then it's, I wouldn't say pointless because it's not, but you don't have the same gain, and I would like to hope that in a future version of this that you can have the compression gain of at least some of the packs. If they're truly random, of course you don't, but sometimes it's a repetition of totally random, the same totally random content, and then it compresses nicely.
Okay, I see what you're saying. Yeah, a good point.
Thank you. Who's up next?
Okay.
Hi there. So for a number of years, the IETF community has been attempting to demonstrate that we don't really need ICANN. And we've done this by registering names without any central coordination. And we haven't had any problems. So by demonstration, we don't really need to worry about having a registry for what I'm calling attribute leaf names. And those are names that begin with an underscore, and they're used to aggregate certain kinds of RR records. And the RR records don't work very well at scale without this. So SRV and TXT are the usual culprits. Although there's a recent addition I hadn't really known about until very recently called URI, which has ended up proving even more distracting because it adds more complicated rules. And as near as I can tell, it hasn't gained much use, but it's still sitting there in the standards arena. So some years ago, after DKIM got going and we added to this game, there was an attempt to put a draft forward, and this working group adopted it and dropped it. And so we're doing it again. There was a little bit of activity when this was first brought into the working group again recently. There are some comments that I need to bring into the draft, but they're relatively minor, relatively straightforward. And then there's a couple that are a little less so. The challenge here in between the original version of this draft years ago and now is that the use of underscore names sometimes is multi-level. So SRV, for example, introduces 2 levels of underscore names. And the original draft I did tried to deal with all of that, and it created quite a messy thing that was not clear how to resolve. And where the current draft went with that is to say that the subordinate levels are local scoped and therefore can be ignored, and that it's only the top level of the name use, which constitutes a global namespace, that we need to put into the registry. And that's where the current draft is at. The issue that leaves is that in particular the SRV specification and the URI specification do a kind of registration inheritance. They say that some of these names are taken from some other existing tables. Well, the only way to resolve that is either to go back and change those specs so that those names that get used get registered in this registry, or to somehow ask IANA to do real-time name conflict detection. And the folks at IANA are nice people, and they like to say yes, and so they've said they could do this. I think it would be a horrible choice. John Levine is more sanguine about it than I am, but I think that asking humans to make real-time conflict detection on an ongoing basis with absolutely perfect detection is not a reasonable choice. And so my view is that we should go back and fix the SRV and the URI specs to yes, thank you, Andrew. That was the reaction I was expecting. So therein lies the problem, is touching those specs is its own problem, but we have an inherent name registration conflict. And that's the only interesting task that I think exists for this draft, other than getting you folks to comment on it. And you may have noticed on the mailing list, I tried to do that, didn't work very well, we can try some more.
That's why you're up here in front of the room with the target painted on you, because actually the chairs agree this is important work. It's high time it got done. But it can't get done unless people comment.
Right. There was a second slide and you went to it. Thank you. That was perfect. Yes, actually, I've already said what's up there. So, yes.
This is Andre again. I have just a small nit. You are missing TLSA.
I'm sorry?
The Dane TLSA, because they also have underscore.
Okay.
Missing them from the draft.
That's not in the table yet. because that came later than the original draft, and I didn't update that adequately. So yes,
So
there's
it's
entries.
just
There's
an-
entries in the table that need to be added. Thank you. Would you post a note? I don't think that got it onto the mailing list.
Okay, I will
And-
post it in the mailing list so it doesn't get forgotten.
Okay, thank you.
Hi, I'm Jim Fenton. I think this is important work to acknowledge what's become a widespread use of widespread practice in DNS. The one thing that confuses me is the word leaf, because, for example, in DKIM you have a selector name dot underscore domain key dot domain, and it isn't a leaf node that has the underscore. So I think if you left the word leaf out, it would be a lot clearer, because even some of your examples involve underscores at other than the what I would consider to be the leaf, the uppermost level.
Yeah, I'm thinking about that as you say it, and our records only occur at leaves. I think that's right. It's not right. Then there probably does need to be some use of. No, of course they don't. So yes, I think that the intent I had in mind is probably reasonable. Getting the wording right might be a bit of a challenge.
Yeah. We're under some time pressure, so I'm closing the mics for this, but go ahead.
So therein lies the demonstration of Canadian versus American. He was close enough to the mic that American would have said, "I'm in the queue."
Lars Lima from NetNode. Two comments. I think, yeah, the underscore is there, but there is no record at the underscore in that intermediate's name. So we can haggle about the leaf part. I'm on your side.
I wasn't disagreeing with the fact that the wording needs to be more careful.
That's good. Now to my real comment. Do you have any feeling for how many specifications do we need to fix? How much work is there ahead of us?
Oh, I think it's only the two that I cited that are at issue. The number of names that we have in the current table are over 40. There are over 40 entries. There are over 40 specs that are using underscore names. That doesn't mean they all need changing. I think it's only SRV and URI that need changing.
Okay, and for the rest of them, it's just a matter of making a catalog.
I think so.
Okay, thanks.
Yeah, I'm John Levine. The situation is actually, for Andrew's ulcer, it's actually less dire than Dave suggests. SRV is fine. TLS, no, in terms of colliding names. TLSA is fine because the subnames it uses are all prefixed numbers, and SRV uses service names that have to have letters in them. So in fact, the only spec that could stand fixing to get rid of the only spec that needs to be changed to get rid of all the collisions is URI, and it is my understanding that is not very widely used yet. So I think it's not ridiculous to think about going back and fixing it. Other than that, there's a bunch of stuff to clean up editorially, but I think it's actually not all that hard to do.
Brian Dixon. It's just a thought, but if you're going to have a table, is there any value in enumerating that table, associating with number with each entry, and then using an NSEC3 type bit field? So at that apex, where there could be many different underscore things, you can do one query and find out all of them and figure out if the thing you're looking for is there or not, rather than do many, many queries. Just a thought.
I think the answer is no.
There and then Paul.
Stuart Cheshire, quick comment on this particular slide. I agree with the broad effort you're doing about cleaning up the ambiguity. On this particular one, RFC 2782, I think we fixed that, or at least we tried to, in RFC 6335 that updates that and defines.
I think you posted a note about this, and I apologize because I dropped that bit. I think this correction got raised, and I completely forgot about it.
Actually, that wasn't me, but probably the same point, yeah.
Thank you. Paul Vixie, RFC 2782 author. There's some history here that ought to be probably added to the document in some form. So at the time that the SRV record was proposed, the RFC editor and Diana were the same person. And he came to me and he said, Paul, underbars are bad. You just went through a war about that in Bind, making underbars not work in host names. So what the hell are you doing? And I said, these underbars are not part of host names. They're not going to be used in host names. In fact, the purpose of the underbar is like X dash in the RFC 822 header.
And we deprecated those.
I'm aware of that, but anyway, I said it's like X dash, which was not deprecated at the time, in that it's just designed to keep this from conflicting with any normal use. That's all it's about. And on the strength of that, he agreed that it did not need a registry. Now that everybody else is also using the same Dodge in the same way, I see that we need a registry, and I just want to make sure that it's understood that this was considered on day 0. And we got the wrong answer. Thank you.
Just like S-Dash.
So please comment on the list about what the registry should look like, how that ought to be done. Thanks, Dave.
So the bulk RR draft, which some of you may be familiar with, John Woodward presented in Berlin the basic idea of what it is. It is the baby of the fellows at CenturyLink, and unfortunately none of them could be here, and this is why I'm giving a quick update on the status of the draft. At the moment, it's not a working group item, but we are working towards making it a working group item. I don't know if that's something we'll be taking a hum on today, but we are interested in having it adopted. So the basic idea behind the bulk RR was a way to programmatically be able to generate answers in a more concrete way than wildcarding gives you. And this is probably the biggest source of whatever objection might exist behind it, because there are some people who have always kind of regretted that the IPv4 reverse tree, for example, would just be programmatically generated, so every host would have a reverse pointer address. Not everybody, this is the controversial part though, right? Not everybody is opposed to that. Certainly when IPv6 came along and people said, oh, woe is me, we can't do the same thing in IPv6 because there's way too much data there. And people are like, great, we'll kill off this programmatic generation. There is another set of people who still find it very useful, and it actually extends beyond the reverse tree, being able to generate sets of names based on patterns of numbers. And right now, the way you can do that, probably the most common way that people are familiar with, is with the $generate statement in bind. The problem with $generate is it does generate an entire, all the records, and so when you need to then transfer them to secondary servers, it transfers the entire record set. And Bulk tries to make that more efficient by being a transferable record itself, which then gives you a programmatic way to generate the records you need to address. It also then tries to cover some of the existing problems with wildcards, some of which we have recently encountered in a different context, but basically wildcarding rules don't quite work the way that people expect them to work. And so by people, I mean people outside this room. And those collisions that can happen with wildcards, where all of a sudden you're not getting a wildcard answer generated where you think you'd be getting one, Bulk helps to more clearly deliver on the expectations of people setting up their zone data. And in addition, one of the things that I really appreciate that John and Dean and the CenturyLink team has done is they, rather than just saying, as is often the case of, oh, I want to be able to dynamically generate records and the heck with DNSSEC, they've actually come up with a way where they're really trying to make these dynamically generated records compatible with DNSSEC in a pretty efficient way. And so we can. And I think the next slide is my current status of where things are. Well, next slide. There we go. So there hasn't been much ongoing discussion on the list about it. One of the things, again, that so I should point out that this is the first experience as the CenturyLink guys are having with working with the IETF, and I think they've been doing a fantastic job in that they were very responsive to comments on the draft, tried to incorporate them. But then lately they kind of noticed that there was a fall off after the last revision was posted, and so we're trying to put a little bit more steam in it. We are doing some revisions now to try and make, I think we can actually skip the rest of this particular slide. Besides, we're going to be looking for reviewers on the draft, which is not yet available, which I will describe on the next slide, what those are. And so one of the things about the draft is it is very long. It includes both the processing for bulk and the DNSSEC processing by another record that they call NPN. It has a lot of external references that it really doesn't need as a DNS document, because, I mean, we can incorporate them more succinctly than they have been so far incorporated. And it also doesn't have really great flow. So one of the things that I'm helping them with is trying to make it become a more readable document without quite so many forward references and jumping around, and just taking as understood within the DNS community some things that should be well understood by anybody that would be reading the draft. There are also a couple of limitations in the draft. Like right now, they only allow a specific set of Q types to be used with it, and it was an unnecessary restriction. In the same way, they also had a limitation to being only US ASCII, which in the domain name space is not really a necessary restriction that they had to have. And so we're trying to clean up all the other aspects around the DNS protocol writ large beyond just the specific use case that originally provoked their interest in coming up with this record. And as I mentioned, that NPN for DNSSEC verification, it might make sense to pull that idea out into a separate draft, kind of like the way NSEC 5 pulled BRFs out into a separate draft. We're not really sure on that yet, and that's going to take some more discussion within the people particularly interested in DNSSEC as to what makes the most sense there. And I think that's basically it.
Yeah, we have a couple minutes for real quick comments, but also what we're really looking for here is more review. So Paul Hoffman is over there, and anybody who's willing to have their name on the hook as a reviewer.
Oh, and speaking of Paul, one of the things that also we do want to take into notice is we are very much aware, especially I in particular, as I'm asking for 3 different drafts to become working group items, that the working group does have a lot on his plate right now. And while it would be great to have it adopted and taken on as working group item, we realize that there's limited bandwidth and there's not a great sense of urgency about this, but to the extent that we can.
Right. Well, what I'd like to see is the shorter, the next rev in shape to be possibly considered. So Paul, I hope you're looking at who's at the mics, because going to the mic for this is automatically you're volunteering to review it on the list.
Well, and Andre was the fastest, so.
This is Andre. Sorry. I generally like the idea, also because, well, speaking with my DNS server vendor head on, because we already have something similar in the Node DNS, but I think this is over-engineered. It's too complicated, and I've heard screams when Bert from Power DNS suggested Lua record, but you are putting regular expressions inside the DNS servers, and I feel that's dangerous. I think that if this is going to fly, then it needs to be much simpler. So you not do the placeholders and stuff like that, and just pick something that works generally. And this is too much complicated. Same with the NPN. I will do a proper review, but from what I've seen, this is too complicated to be implemented in the DNS servers.
So I'll point out both. So for one, it's not full Rego expressions, at least. But then the other thing that I think that's a really relevant point is, as you mentioned, Power DNS and Lua, and we actually Akamai has a name service mode that does work with full Rego expressions, and the problem that I see with that is that it causes unnecessary lock-in. And so the one thing I really do like about this draft is for cooperating implementations, this, it is a public standard that then could be used no matter, as long as your server implemented it, could use this across the wire, and it doesn't matter what the endpoints were. Whereas right now, if you wanted to use a service like Akamai's patterns name service, you're locked into the specific way that we do it. So I actually appreciate that this tries to avoid the lock-in problem.
Center microphone.
Stefan Botsmeyer, Hafnik. Is there any running code today? Because it would be a cool project for hackathon, and because it would help to address issues such as is it too complicated, is it too slow?
Right. I would actually have to ask John, who I think is listening in on the conversation right now, but I'll have to get back to the list. I'm personally unaware of it, but I don't know if they have something inside CenturyLink that's going.
On the personal remark about NPN, I think it's really cool. I'm a big fan of RFC modularity, so I think it's a good idea to make it its own RFC. But in the current text, NPN, I was not able to understand the text. The pseudocode is much better. So I understood the NPN only from the pseudocode.
Right. Right.
Brian Dixon, Perl hacker, currently at eBay. I was wondering, there's the back reference syntax that looks a lot like the Perl references.
Right.
I was wondering why you don't currently use the parentheses notation for what those point back at as a delimiter. I think it would work a lot better or make it a lot more deterministic and probably be easier to implement.
Yeah, so I agree that there are some finer points of some of the ways the record is specified. That's the way we're trying to clean up. Like, for example, there's also that one name includes the full, the fully qualified domain name, and then the pattern doesn't. And so there's bits like that that do need clearing up. But I think that's something that, we pursue on the list, through discussion on the list, so we have a good record of it.
I'm Jim Metatia. I'm basically agreed with Andre. I read the current version of the draft and it seemed too complicated. I think the basic motivation is pretty good, but if a working group is going to adopt it and work on it, it's probably better to focus on simpler scenario and finish it first, and then think about the more complicated things.
We would welcome all, alternative, simpler ways of achieving the same end. So.
Microphone's closed, but go ahead.
Well, very briefly, I've been over at NL Labs actually with Jinmai and Andre.
Mm-hmm.
We have the same position for NSD. Yeah, so we like the idea. We're definitely interested in discussing these kind of solutions. But
okay.
Yeah. Thank you.
Yeah. Great. John, you're the last one, I think.
Yeah. John Levine, I'm concerned that this is proposing a fairly fundamental change to the way DNS servers work. I mean, existing servers can take static zone files, you can sign them offline, and the server can simply serve what it's got. This demands that servers do generate RRs on the fly and demands they do online signing. And I'm not opposed to that, and I think this would be a dandy thing for Stunt server for handling your V6 reverse DNS. But it feels to me like swatting a fly with a hand grenade. It's an enormous amount of new special purpose stuff that is somewhat hostile to the way that I mean, your name server does all sorts of magic, so it's fine for you, but for those of us that are running NSD on a little server this big, it's a lot of stuff that I would not be happy to have crunching away inside an existing name server.
Right. The obvious response being, well, then don't have your name server do that.
Yeah, so long as, if it says in large red letters at the top, totally optional, feel free to ignore. I would be less worried about it.
Right. Understood. Okay.
Thank you. Yeah.
Hi, I'm Paul Vargas. So we presented this draft last time. This is about obsoleting old DNSSEC algorithms and trying to cut the long tail of DNS a little bit shorter. It was fairly uncontroversial until somewhat recently. Everybody seems to agree on that we need to do this, and it's all a matter of what can we actually push. And this document tries to find a balance between reality of what's deployed and sort of pushing that reality to a newer reality. So we don't really want to say cut this off. As of tomorrow, you cannot use this algorithm anymore because it's not realistic if those zones are still there using it. So we try to find this balance, or we try to push things down a little bit faster than they would without this, without causing problems. So next slide. So this is basically the first table. So you see all the algorithms, and they're marked in these RFC 2119 keywords, except that we added some modifiers like the minus and the plus symbols. Minus basically means this is the current requirement level, but we would really like to move this down if it's a minus, or we'd really like to move this up in the future when there's a plus behind it. So it's a indication of where we expect this algorithm to move to. And then hopefully implementers will take this as a sign about how important it is that they support this this algorithm, or how important it is that they still have to support this for a while. And then, so if you do the next page, you have the one for the DS records. And I think most of these are uncontroversial. So then the next slide is so what do we have left? So some people said that they really didn't like the plus and the minus syntax. Other people seem to have no problem with it. This comes originally from the IPsec working group, where we've done this on a number of iterations of these documents. So they always obsolete the previous one, so you only have to look at the last version of the document, and then you can see what the changes are. I think I would like to see a little more input from the people about whether, like, if they really cannot live with this, or if they have some other better syntax that would also result in a really concise table and not like a bunch of text in the document that gives that implementer a quick, good overview. And then the other issue, other than some minor updates that we need to do, is the killing of SHA-1. Everybody here in the room would like the SHA-1 to die immediately, but unfortunately there's just too many zones out there that are still there. So we need to do this gradually and push this, and there are some different opinions on the list on how fast we can do this.
Yeah, Roy will actually be talking about his draft, which also overlaps the question about SHA-1, but go ahead.
Hi, my name's Andrew Sullivan, and my former co-chair, Olafur, is up there in the front, and I think that he will recognize what I'm about to say. We tried a very similar trick to update the registry, 5-6 years ago, and had a painful fight over adding this syntax to the registry. And it took more than a year. And the reason I didn't send this to the list is because I went digging in my archives and began to weep, and I stopped. So I don't think I like the approach. I think it's perfectly fine, but you're going to face the same fight again when it gets to IETF last call, because the area director who was standing in the way at the time is just as likely to file an appeal this time. So
sorry, can you clarify what you're objecting to? The syntax or the method?
The plus minus should.
So if the new RFC graphics awesomeness things allows like arrows up, arrows down, would that be acceptable?
No. The claim is basically that registries are not the place to make normative claims of this sort, and the place to make normative claims.
This is not going in the registry. This is an RFC.
So you're going to put it in an RFC, and you're going to reference it from the registry?
Correct.
Oh, I didn't understand that in the draft. So that's probably because I read it badly. But so that probably affects things. But that was actually the basis of the fight the last time.
No, we're not. We'll add the pointer to the document, but no, it's an RFC, not a table update at ANA.
Okay. That actually just changes the entire thing I was going to say. So I'll shut up now. Thank you.
I think when we originally did this front order, we wanted also Roy to be able to present. Do you want to wait until after we take this queue, or do you want to? Okay.
Very specific to.
Then we'll take the questions specific to this draft. But for folks who have read both drafts, we were envisioning a discussion on both, and Roy hasn't had his chance to speak yet. So we'll take the questions here if they're about this draft specifically.
John Dickinson, can you pull up the first table?
Sorry?
So when I recently signed a zone, and when I read this table, I couldn't work out what algorithm to use.
One of the must algorithms would be best. Obviously.
I mean, there's only one that's must.
Well, then you should use that one.
So I should have used RSA SHA 256. That's the only must on the list.
No, yes, because so for the elliptic curve ones, there's still a deployment issue on how far deployed they are, so that's why they're not a must. If you think that by now has changed, then we can discuss on changing that changing the values for.
I used DCDSA something or other, so I don't know if that made the right choice or not. But I found the minuses and the pluses very confusing. Trying to make a decision about which one I should use that will be future proof, so I don't have to resign my zone with different keys.
So what you're really asking for is because remember, this is for mandatory to implement, right? So this is not really for what you should use when you start using a zone. So what you're actually asking for is sort of a recommended default. And without ruining all of Roy's slide, I think that he is proposing a BCP document for that, which would be not this document.
Okay.
Yep. I'm not going to propose that, Paul. I'm going to beat you up for the line for number 13. Why is it should minus and must minus? That means it's being phased out instead of being phased in.
So yeah, the minuses tend to the minuses mean it's about to be phased out, or we would like it to be phased out. So it's less important, and it's becoming less important in the future. So must minus means you still must implement it.
256 not the same way. It should be phased out. The keys are getting too big. The signatures are getting too big. You are encouraging DDoS attacks by doing.
If you think that, then we should discuss that specific algorithm on the list and come to a working group consensus on that.
This is DKG. I'm not going to comment on the pluses or minus suffixes. I'm just going to comment on Andrew's earlier remark about registries not being a place for this kind of recommendation. I'm pointing out the transport layer security working group is actually adding working group recommended yes, no, not pluses, minuses, just yes, no to a number of registries associated with TLS. And it seems actually fairly uncontroversial within the transport layer security working group. Okay, so my point is that, putting something like this in a registry doesn't strike me as outlandish in general.
Christian Wittemar?
My clients are closed for this draft specifically because we do have another crypto algorithm draft to get to. But go ahead.
I belong to the people that Paul was mentioning who didn't like the plus minus kind of suffixes. I still don't like it. I told you so in the IPsec draft.
If someone can come up with a different syntax that can be in the table, because the only alternatives I've heard so far is people saying under the table, write whole paragraphs for each algorithm to explain what it wants. And then I think it loses the clarity of this.
That you have basically, I like personally the idea of having a footnote on the algorithm saying this one will be deprecated soon, which is one of your constraints.
Right. So you're suggesting remove all the plus and minuses and only explain it underneath it.
Yes.
I mean, if that's the consensus, then we'll do that. It's not my personal preference.
Because I mean, what you want to say, for example, in relation to RSA SHA-1, it says, yeah, you must do that now, but it will change soon because SHA-1 is unpredictable. People have to understand why, especially in an RFC. In a registry, well, it probably what's belong is some kind of a column like what they do in TLS. But
so it does have those explanations under the table, but we tried to make the table, or I tried to make the table like as standalone as possible, because we know how implementers implement things. They just look at the tables.
So look, I mean, take your table there. It will not terribly hard to have a five column width at the end saying yes, no. It will not be very hard. Maybe much easier.
Yeah, let's on the specifics of the semantics. We can take it to the that we really should take it to the mailing list. We knew we would have to hash it out there.
Brian Dixon, I was wondering if any thought had been put into using something that hardware vendors use, end of sale and end of life. So like a deprecate date and a dead date, and something that's in the plus wouldn't have any of those. Anything that's in a minus would be, okay, stop using this after this and don't support it after this
So
date.
So
I
the
mean,
thing is,
the
this
date-
is really an interactive process, right? So when you put out this document, you're trying to push the community to do something, and when they do it, then you can actually follow up a year later with an update to this document to push them again. If you just put a hard-coded deadline in here, it's either going to be ignored by everybody, or everybody's going to I mean, if putting a deadline in worked, then we wouldn't have this problem in DNS.
If you put the deadline with some low level of granularity, like second half of 18, something like that. Anyway, just a thought.
Yeah, I don't think it's realistic to put deadlines in because real life interferes with that.
So just a comment about the minus and plus.
Your name, please?
Daniel Migo. So we had this discussion in IPCKMA, and we didn't really find a better way to do that. So I think that's definitely the good way to provide that, because a must or a must minus is really not the same. The minus just indicates that we just keep that for interoperability and we want to deprecate it. So that's what happened in at least IPCKMA.
This is my RFC author head on. I like what DKG said. So would it be enough to just remove the plus and minuses and add a column with recommended yes, no? Would it solve? But okay, we'll do that.
Saruman, go ahead.
Evan Hunt, ISC. I'm fine with the terminology. The pluses and minuses are not confusing, and I'm fine with the DNSSEC signing column. And I think I said the same thing when we discussed this in Buenos Aires. I'm not sure. It does no harm to implement something in a validator that isn't being used by signers anymore. It's just code that doesn't get used. Having an MD5 validator doesn't hurt anybody. So I would recommend keeping substantially similar syntax, but in the DNSSEC verification validation column, I would recommend not going further down than I would be at must, should, and may rather than.
So one of the reasons here is that if someone writes an implementation from scratch, they know what they don't have to implement. So then they don't actually end up implementing code that will then never get used.
The problem is that must not sounds like you're out of spec if you do implement it, whereas I would say may. You're allowed to. It's pointless. Optional. Not recommended. But
Roy, do you want to go ahead? Yeah. Yeah, we are going to run out of time. With apologies to those of you who thought that we only ran out of time in the past because we had to talk about special use names. I think it's just that we have a lot of work to do. But go ahead and we will just go through until we're out of time.
Hi, my name is Roy Adams. I'm one of the authors of this document. I only have 72 slides, so bear with me. Anyway, if you go to the next slide, please. It all started in RC 2065, the very first DNSSEC standard. In light of many different potential implementations, you have a potential of having various different algorithms to support. The problem is that in that case, if you have a distinct set of algorithms in one implementation from another implementation, that you can't validate. And so the idea was at the time to come up with a mandatory to implement, so there was at least one algorithm that all implementations could agree on. That was RSA MD5 for 2065. For the update to that, 2535, RSA MD5 was deprecated in favor of DSA. And then came 4034 and 4035, and DSA was deprecated in favor of RSA SHA-1. Now, in order to deal with all that spaghetti, Scott Rose wrote a applicability statement, that's RC 6944. It's very clean, very simple. It has this table, and it says RSA SHA-1 must implement. My proposal is to change this table. Next slide, please. RC 6944 has a few guidelines if you want to update this. Number one, this document is not meant to be a discussion on algorithm superiority. And I say this number one, even though it's the third line on the slide, but bear with me. The other two are very simple. If you can't update 6944, you need to replace it completely. And if you do so, you need to use this table. Next slide, please. So this is the table you just saw on the first slide or on the second slide. And can I have the next slide? This is the only change I'm proposing. I'm proposing to put RSA shall 1 from mandatory to implement to recommended to implement. In real life, implementers, they will support what their users want them to support. So overnight, bind and unbound won't lose support for RSA shall 1. However, next slide, please. Also, this table won't be updated. There might be a reference to either Paul Wouters and Andre Cerise document or document I'm proposing, but in fact, there is no, in this table, this is just a code point for implementations to use. This is the IANA DNSSEC algorithms table. And so, next slide. So nothing changes really in that document. Last slide. Sorry, next slide, please. So then why bother, right? If you don't update the table and implementations are really not going to, you can't implement the idea that a couple of months from now, you can't use this algorithm anymore. Implementers know better, developers know better. They know what their users want and they understand how this works. So why bother? Basically, is to give a new default, and hence the title of the slides, give a new default to implementations. If you take, for instance, and I'm not trying to single them out, they're actually following the draft to the spec. If you take DNSSEC keygen, which is an implementation, it's a tool that comes with bind. If you don't specify any algorithm, it defaults to RSA shall 1. It's a simple thing to update, and I hope it will do in the future. But this basically helps implementers to follow that guideline. Last slide, please. Oh, sorry, there was the last slide. The last point on this slide is any other advice, in my humble opinion, should not be on a standards track. It should be a BCP. So my proposal is the stuff that Paul Wouters was talking about just now. That should be a best current practice. That should basically implementation guidelines. That normally goes into a best current practice. It should not update any IANA tables. Thank you.
Hi, Roy.
Hi, Mark.
Mark Andrews, it's actually hard to change defaults. It is really hard to change defaults in existing software.
Yes.
Because you've got people out there that are using, you say DNS keygen, using the defaults. We change the default, we break DNSSEC for them. I can't change that default in that program. I can produce a new program with a new default. We've got to manage the transition of algorithms. Just saying change the default is very, very difficult for operational reasons.
Now, I completely understand you can't change the default, but I also hope that you understand you can't keep RSA shall 1 as a default in your main tool forever, right?
We've got to think about which bits of software change. You've got to have software that can do a managed change of the algorithm that's used in the zone, actually do an algorithm transition. There's no such thing as an algorithm role, it's algorithm transition. And just saying the default, changing the default for a new bit of software, specifying the defaults for new software is easy. It's when you got this old software out there, you just can't change the default.
I understand where you come from.
Medica K of Farsight Security. So I love this. And the reason I love this is because I've been working with crypto for 20 years and seeing the disasters in an operational community. So I always laugh when people say, let's encrypt everywhere. I'm like, oh, that's going to be fun to watch. So the 3GPP folks have gotten it right. When they did TLS in their spec, they, out of the 300 something crypto algorithms, they said you must implement it was AES 128 big keys, right? I mean, that was the minimum, right? And then everything else you choose. What did people do? They had interoperable crypto because everybody did 128. And then maybe some of them added a couple others later on. But part of the issue that we have overall is when something gets deprecated in the industry, and so those of us that know TLS, remember Poodle. I was so happy, even though I was a CISO and I had a really bad 2 days, but we got rid of SSL v3, right? And people are starting to look at TLS 1.1, 1.2. Thank goodness, right? So we have to get to who's going to make the jump. From my perspective, the implementers need to know who is the person that says, I don't know what to implement. Do at least this one thing, right? And then you can make other choices when you have a best current practice kind of document that explains things.
Thank you.
We're closing the mic lines for this now so that we can fit in one more draft, but go ahead.
Oliver McLaughlin. Roy, quick question. You have here a table of what is recommended to implement. Your document does not have anything what is recommended to do by operators or users. Is that intentional or omission?
This is an applicability statement that if implementations implement something, that at least they implement RSA SHA-256. One reason for that is, for instance, that the root zone is signed by RSA SHA-256. Many GTLDs, many CCTLDs are signed by RSA SHA-256. We're not deprecating anything else. We're just moving sideways, moving slowly towards the future,
So
without having all the spaghetti. Sorry, Paul.
So why aren't you giving better direction to people who are starting to use the NSX?
Well, I think that's a very good question. And the idea is that I put up there is that these guidelines for implementers, operators, people who deploy, even users, they can go into a best current practice because simply that's where it belongs. So I'm not opposed to Paul Wouters and Andre Suri's drafts. Absolutely not. I think it should be a best current practice with good guidelines for implementers and stuff. However, the applicability statement allows a simple change to move away from RSA SHA-1 and let RSA SHA-1 in the future with the next update, in the same way this is done, to go the way of RSA MD5. Paul, do you still love me?
I still love you. So I have two cosmetic problems with what you do. So if you go back one slide, is any of the chairs awake? Go back one slide. Who has the clicker? Chairs? Go back one slide. Maybe two slides. Further back. Further back. Yeah, that one. So I here see, if someone casually looks at this column, they see recommended SHA-1, which is definitely not a feeling I want to share to everybody. Like, I really don't want to tell anybody SHA-1 is recommended for anything. So it's a readability issue. The real practical issue I have here is if a new implementer comes and reads this and says, oh, SHA-1 is only recommended but not mandatory, I will just not implement it, they will actually create a broken product. And that's my real problem with the draft. And that's similar to where we have a disagreement about BCP versus the mandatory to implement. A mandatory to implement is a little harsher than a BCP because we're actually making sure that the algorithm is going to get tainted for new implementations and that they cannot really use those old algorithms anymore in the future.
Okay.
Evan Hunt, ISC. Once in a while, I have to disagree with my beloved colleague, and this is one of those times. We have to change the defaults.
Shall I leave while you disagree?
What's that?
Shall I leave while you disagree?
No, I don't want to get into a throwdown here, but I just wanted to say for the record that I don't think that we are going to have to keep the keygen defaults the same. They have to change. And I will get bug reports because people's signing scripts break, and I will experience regret for not having thought more about this 8 years ago. But anyway, I just wanted to put that back out onto the record in a different way. Thank you.
Okay. Thank you. Chairs, the floor is yours.
Thank you, Roy. Thanks, everybody.
Thanks to the chair for squeezing me at the last minute. I'm a little under the weather, so hopefully I'm audible in the back. How many of you have actually skimmed at least or read this draft? Yeah, it's about what I expect. Very good. So you'll notice I've underlined a keyword here, an operational implementation draft. You may be familiar with another one that's almost the same title, but implementation. There's a little bit of a difference. I'll explain that briefly. Next slide. This is the gist of the draft. It's to encourage operators to allow DNS over TCP traffic. Next slide, please. So I had a former student come to me after taking another security architecture class who described a situation where they formulated a network plan and they built a firewall in this capstone project, and they designed a firewall rule set that said, we'll allow DNS traffic over UDP and TCP, and then the instructor said, no, hold on there a second, no, I wouldn't do that, I would block the DNS over TCP, and this student made the mistake of saying, well, JTK said. So then I had a discussion with this other instructor about that, because I disagreed with that stance generally. And this is just, I cherry-picked some of the quotes that came out of that discussion. And when this came back, I sort of clasped my hands together and I said, okay, let's do this. Let's get down to the blood in the water and see if I can eat this person out. So I later looked at it and I said, what if, can I really make a strong claim here? And I went and looked through a number of RFCs and found that it's actually difficult to totally dispel this notion, to say that you must allow DNS over TCP. I think many people in this room, maybe most if not all, certainly many in the network operator community seem to believe this, but not so much in the security community think this is true. And there's a variety of reasons for that. In the draft, I described some of the history behind why that reasoning exists. And you can read about it there. I won't go through all the reasons for that. Next slide, please. So here's the outline of the draft. I'll let you read it. Some parts of this are more or less complete and perfect or imperfect. Probably the first part is probably the most complete. The other parts are sort of being worked on. Contributions are welcome. Next slide, please. I've gotten some feedback initially. Thanks very much for those of you who provided that. These are some of the things that I've been told. I'll just simply address maybe that second bullet point, that RFC 7766, that's the implementation requirements draft. People suggested to me that perhaps that document was enough. And I felt that it wasn't, because in fact, it specifically mentions in the beginning that it provides no guidance to operators. And so that was actually part of the problem. Maybe it could have, but unfortunately it didn't. So that's largely the genesis for this draft for me. Next slide, please. So to conclude, these are my questions for you. And these are questions that have been brought to me as well. Must and must not, I don't know if we can put those in operational oriented draft or document. It's suggested maybe we couldn't. I think there's some precedence for that, but I don't know, you tell me. I'm not that familiar with implementation history. Early versions of Bind, were there performance limitations with DNS over TCP? If people have information about that sort of thing, I'd be certainly interested to know, and we can say something about that here. I have some measurement data that I can provide for some of this, but if any of you have more, particularly something that can be referenced, I think that would be helpful. And finally, is this the reason this is new work? Is this something that's worth working on? Should this continue? So with that, I'll let the chairs field questions.
Hi, this is Andre. I like this work, so I think it's definitely worth pursuing. And to answer your first question, I think you might do this as a BCP, not an internal standard, and it'll help with the first question. So do it just as BCP, but I really like the effort, and I think we should have done it years ago.
Thank you.
Jeff Houston, APNet. We did some extensive measurements on this about 3 years ago. 17% of resolvers will not use a TCP follow-up question when you give them a truncated UDP. 17% of resolvers. That affects around 6% of users. So around 6% of users, a truncated answer does not involve a follow-up to TCP from the first resolver. Most of them go to a second resolver from acceptresolve.conf and get the answer. 2% of users do not. So around 1 in 50 users get stranded if the only way you get there is TCP. I might add that root servers A and J truncate quite low. In V6, they truncate at 1280. During the key roll, the DNS key response goes up to 1425 octets. Those folk are getting into more and more nowhere land. So yes, it's a real problem. And, you know, some kind of practice is out there that needs to be stated that TCP is part of this. And yes, if you think 2% of users is a big number, then that's the folk who are actually stranded on this. Thank you.
I got to the mic this time.
Well done.
Yeah, Murray Kucheravi. We had problems in DKIM with, we store hashes of public keys in text records. Evil as that may be seen by this room. It prevented some people from going up to larger keys because they don't fit in the UDP answer. So this is applicable to Unsupported applications. It would be nice to see this done. There are other issues that prevented this as well, but solving this would be a step in the right direction. So we support this sort of thing happening.
Okay, thank you.
Yeah, Paula Bridgman, Comcast. I certainly have enough arguments with security folks about why TCP is necessary, both on our customer side and on our corporate side. Having some documentation that actually says, here are the trade-offs, here are the considerations, and having it all in one RFC. Trying to get security folks to read 8 different RFCs in a particular paragraph is a losing battle.
Very good, thank you.
Ray Bellis, ISC. When I wrote 5966, which I seem to recall was in X rather than OP, we got a lot of pushback because I tried to make that into an operational requirements document, and that pushback was why that's actually described as an implementation requirements document. I would love to see this go through and actually have real operational guidance in it.
Okay, thanks for the background. Very good, thanks very much.
And we are unfortunately out of time.
So there's a couple of authors who are not going to make 2 because we ran out of time, and I apologize for that. We did upload all the slides, so because it's kind of hitting the 3 o'clock time. Ray, you're next, Ray. We're sorry. I can put you up right now. Yeah. So, but
Okay.
Yeah, we had already started a conversation with Warren about how to manage workload better, and we'll be going to the list with some ideas. But for now.
Okay, I'm Ray Bellis. I'll try and keep this very quick. First slide, yes, thank you. So this is a proposed solution for a minor problem trying to solve with the increasing prevalence of front-end proxies and load balancers in front of DNS servers. Got to be clear, this is very much on the inbound path of resolvers, hence why it's on the right-hand side of the diagram here, that you'd be injecting something in a packet to tell the back-end servers what the source IP address was of the client, less allowing the server to use its existing ACLs rather than believing that the source of the packet was the outbound interface on the load balancer. There's, for example, the popular DNS dist front-end software from Power DNS. They're doing something like this, but they're abusing the eDNS client subnet option to do so. So this is a very simple packet, eDNS packet option. Next, please. Simply to allow this to coexist alongside eDNS client subnet. Had a few minor questions on the list about why not use the IANA protocol field, which is a 16-bit field. At this point, my view is simply no need. DNS is not specified for any of the other protocols. It's an IP protocol. So I've just got the 4-bit field there to exactly mirror the IPv4 and the IPv6 version number. So you can just do a straight comparison on it. Pretty much all I've got to say about it technically. I think it's a very short draft, hopefully uncontroversial, could possibly give some help looking at the SIG0 effects. I do have text describing how this interacts with TSIG, but if SIG0 actually matters, then there's possibly some more work to be done. And any questions or got time for a few questions?
Yeah, questions or comments? We're just between you and your cookies at the moment.
Sarah Dickinson. I wanted to make a comment on the privacy implications of this, because I know you've got a privacy considerations section in it.
Yes.
One thing that I think would be nice to come from the working group for this draft, and for example, this would apply to the client subnet drafts as well, is so I see the need for this. I fear the abuse of it. And it would be nice if we had text in there that reiterated the correct parameters for when to use this, and explicitly said that if it's used outside those parameters, it is violating the principle of inserting user metadata into protocols. And that we came up with some text that could be reused across all the drafts that are doing that. Things like client subnet, things
Please
like
send
this.
text.
Yeah, will do.
Okay. Next steps from the question to the chairs is how much work do you think this needs further before we might adopt it?
We're going to take it to the mailing list. Thank you. Thanks, everybody, for your time.
Thank you.
Oh, can I?
Oh, we had one more
Just
question.
in case you are not aware of it,
We had one more
I
question.
sent a comment on this
yes,
draft
Jimmy.
to the mailing list.
Yes, I mentioned that just now. There's the thing about the 4-bit field instead of 16-bit. Yeah.
Thanks, guys.
Thanks for getting it back in there after I harassed you for about a year.
Anybody?